During its life cycle, a mature hurricane can release energy equivalent to a 10 megaton nuclear bomb detonating every 20 minutes. This single weather event generates about half as much energy as the electrical generating capacity of the entire human world, while its cloud and rain formation releases nearly 400 times that amount. This massive energy release operates with the organized precision of a self-sustaining thermodynamic engine. The engine exists to solve a structural problem with our atmosphere. The Earth constantly absorbs massive amounts of solar heat at the equator, creating a severe thermal imbalance. Hurricanes act as natural safety valves, scooping up that trapped equatorial heat and physically transporting it toward the cooler poles. These surface winds represent a mechanical process attempting to restore planetary thermal balance. This process requires a specific fuel source to ignite, vast stretches of tropical ocean water measuring at least 80 degrees Fahrenheit. As the sun beats down, water evaporates from the ocean surface. This rising water vapor acts as a battery, storing the solar heat within the gas. This warm, saturated air acts like a hot air balloon, rising rapidly away from the surface and pushing into the freezing upper layers of the atmosphere. Hitting frigid air, condensation occurs. The gas transforms into liquid droplets to form clouds, releasing the stored ocean heat. This sudden latent heat warms the surrounding air, making it rise faster, creating a low-pressure vacuum at the ocean's surface. To fill that void, higher-pressure air from the surrounding area rushes in. That new air absorbs heat and moisture from the water, rises and condenses, feeding a continuous intake cycle. The storm is now actively converting the invisible warmth of the ocean into the physical movement of air. As that central vacuum pulls in the surrounding atmosphere, the winds do not rush straight into the center. Because the Earth is a sphere, the surface at the equator rotates faster than the surface at higher latitudes. This difference in rotational speed creates the Coriolis Effect, a physical phenomenon that forces moving air currents to curve as they travel across the rotating globe. In the northern hemisphere, this effect always deflects the incoming ocean winds to the right. Because the winds are constantly pulled to the right, they perpetually miss the low-pressure void at the center. Instead, the air is forced into a tight counterclockwise spiral. As the storm pulls in more heat and the central pressure continues to drop, the surrounding winds are sucked inward with increasing force, accelerating the rotation. The characteristic spin of a hurricane is a mathematical necessity of moving air over a spinning planet. That tight spiral of rising, condensing air forms the Eyewall, a dense ring of thunderstorms containing the storm's maximum wind speeds. When the rising air inside the Eyewall reaches the stratosphere, it hits a stable layer of the atmosphere that acts like an invisible ceiling, forcing the exhausted air to vent outward. At the geometric center sits the Eye, a circular core of clear skies and light winds, encased by the most violent rotation on Earth. While the air in the Eyewall violently rises, heavy, cold air from the top of the storm is shoved downward into the center. This high-pressure downdraft suppresses all cloud formation. The clear skies inside the Eye exist because the surrounding engine is operating at maximum efficiency. The hurricane is a slave to its heat source. Without warm water, the engine cannot maintain its internal vacuum. The moment the storm makes landfall, its fuel line is severed. Without the constant supply of evaporating warm water, the condensation cycle stops and the latent heat release ends. As the system loses its upward momentum, it drops its accumulated moisture, resulting in catastrophic inland flooding. Simultaneously, the friction of the land drags on the rotating winds, and the thermodynamic cycle collapses. The most powerful machine on Earth is ultimately fragile, existing only as long as the heat continues to flow.